Hi everyone, thanks for watching laurieWIRED, and in this video we're going to be switching things up a little bit and taking a look at some Linux malware. So we're going to be looking at the BPFDoor malware family, which is just a backdoor family targeting Linux machines, and we're going to be doing some static analysis inside of Ghidra today, and just kind of seeing how far we get through this malware sample, and maybe at the end of this series we will do some dynamic analysis as well. So let's get right into it. If you go on MalwareBazaar and you are searching for BPFDoor, there's quite a few samples that are available to you. I think that most of these samples are pretty similar to each other, but you can feel free to analyze whichever sample you choose. And we're going to be taking a look at the first sample right here. So if you click on that, this is the page to the actual sample we're going to be analyzing today, and I will share a link to this in the comment section of this video. So I've already downloaded this sample, so let's go ahead and open it up in Ghidra. So I'm going to open up Ghidra and also get my folder to my actual sample, which is downloaded right here. So I already have a project for this specific family, but if you don't have one, you can just do File and then New Project right here. But I'm going to take this and I'm just going to drop this in right here. And let's let Ghidra do its analysis. So it's found our ELF file, ELF standing for executable and linkable format, which is basically just the main executable type for Linux machines. And we can double click on this to get our Ghidra analysis going. Yes, we want to analyze. And I'm gonna also select the extra decompiler parameter and click analyze, and let's let Ghidra do its thing. Alright, so Ghidra has done its initial analysis and it's opening up our entry point for us, which is nice, and it's automatically doing this. If we look on the right hand side, we have our decompiled C code. And if we look on the left hand side, you're going to see the different assembly instructions. So this is x86-64 assembly for this particular file. I'm going to be looking at the decompiled code and fixing that as much as possible. So what we'll do is we'll just kind of step through this code and fix it as we go and see what the different behaviors are of the malware family as we analyze this. Let me make my window a little bigger so you're able to see what I'm doing. Okay, so this is our entry point, and we have libc start main, which is just going to be starting the actual functionality of the application. So this doesn't look super interesting. Looks like it's passing a couple functions as arguments to this libc main start. So let me see what these are. This looks like definitely some user code that we have right here. I'm just going to quickly pop over to these other functions and see what they're doing. Nothing super interesting. This looks like some init code. I'm going to name this. You can do rename with L, or you can just do rename like that. And do malware init. We'll just name it that so we know we've taken a look at this. And I'll double check what this is. Doesn't really look like anything. So I'm going to name this malware, return. Alright, these didn't look super interesting, so I'm guessing most of our main functionality is going to be in this particular function right here. So let me start my analysis. Looks like we've got two parameters right here, one an int and one a char pointer. I'm thinking that this is going to be our main function. So I'm going to actually just name this malware. So MW is the prefix I use to describe when I have named a function versus when a function has been automatically named. So it's easy to distinguish that way. So I'm going to say malware main, and I would guess that this is going to be the argument counter and the argument vector for the main program. So let me also rename these, and we'll just say argc and argv. So these are going to be any command line arguments that are actually passed to the program. So the argc is going to be the number of command line arguments that you have passed to the program. And then the argv is going to be the actual array of arguments themselves. So that looks good. Let's continue on and see what we have to work with. Okay, so this is a pretty small function. If I wasn't sure where to start out in this malware sample, I might do search and then look for different strings in this, just to give me a kind of idea of where to start looking at this malware sample, which actually is giving me a lot of stuff as well. There's a lot of plain text strings in this, which is nice, and I like to see that because it makes my job a little bit easier when reverse engineering this. But because this looks pretty straightforward in our main function, I'm just going to start analysis from the top, which is not always the most optimal thing, but I think it'll work in this case. All right, we have quite a few different local variables that are defining some strings. These strings look really interesting, but let me go through them right now and see how they're used. So we have this ivar, which is storing the return value of this access method. So if this has been named and actually automatically given the proper name, that means we can actually look up the man page for this for Linux. So what I like to do is Linux man and then access. Would help if you spelled it right. And then here's the man page for it. So now we can actually look up the functionality of this access method. So it checks whether the calling process can access the file path name. And let's see what arguments it takes. Looks like it's taking 2 arguments. What are our arguments? Here we go. Path name and mode. Okay, that matches the arguments that we have. So I'm just going to go ahead and name this malware path name. And then the mode was an integer value, so that's just passing in the constant 4. I don't really care what that means, but I could look it up if I wanted to see what the constant mode 4 meant. And then let's see what our return value is. So our return value on success, we are allowed to access this particular file or folder. Okay, yeah, it's basically just the successful return value or not successful. Okay, so I'm gonna rename this ivar1. Let's just name it var access return, since that's storing our return value. That looks good. And we can press the center button on our mouse to highlight all occurrences of this particular variable, and that way we can see how it's used throughout this program. Looks like we're checking if it was not 0. And let me highlight. Otherwise we exit the program. So I think if it's not able to access this particular path, then it's just going to exit the program completely and it's not going to do anything. Let me see what this path is out of curiosity. Okay. Looks like this is our path. Maybe it was set earlier. Oh, okay, here we go. So it's set up here. I think this is supposed to be a character. So we can change this to char / maybe the beginning of our directory. Change this one as well. Yeah, I think so. This this looks like a string to me that didn't get properly typed. So what we can do is we can fix the type of this in Ghidra to actually recognize this string value. So let me copy that. And let's just see how long our string value is. Paste right here. It looks like it's 21 characters long. Each of these look like different ASCII characters. So let's change that to a 21 character long array of chars. Yeah, we did include the null value. That's good. So I'm going to right click. Then I can do, whoops, retype, and we can do char. And then inside of the brackets is going to be the size, and we said it was 21 characters long. So let's see if that works. That looks good. Okay. That is making sense. If we want to make this look a little bit nicer, let me just do a little bit of magic over here. And we'll paste this in. And let's try and get rid of the beginning part of this as well as the end so that we can just have the plain text string so we can get kind of a better view of it. Okay. Let me do a little magic with some regular expressions. So we'll do that. And we'll catch everything before that. Nice. Okay, so that's taking up all of that. So we can replace this with nothing. Cool. And then I think we can do Control F. Let's try replacing that as well. Nice. Okay. And we can get rid of the null character. That's just signifying the end of the string. So it's checking to see whether it can access this particular file right here. And if it can't, then it's actually not running the program. Let me insert that as a comment so we can get a better view. So do comment set, or you could just hit the semicolon character. Okay. So we have our comment right here, which says the actual string that we have, so we can get a nice view of it. Moving on, let's continue down our main function. We check our access. Let's pretend that we do have access to this file. Then we're getting the UID. If you are curious what this does, again, we just go to this, whoops, hitting buttons, Linux man, and then the method that we're trying to look up. And we can just go to the man page. There's a lot of different man pages, but pretty much all of them say the same thing. So we have get UID returns the user ID of the calling process. Cool, sounds good. Doesn't look like it takes any arguments either. So let's rename this. I'm gonna call this var. Process UID. There we go. And we do, again, the middle mouse button to highlight all occurrences and references to this variable. And so we're checking to see, is the process UID equal to 0? Otherwise, we still exit and do nothing. Okay. So the process UID in Linux for 0 means that you are running as root. But if you were not aware of that, all you need to do is look it up. So let's do process UID 0 in Linux. Yep, pretty much just has root privileges. So that's what it's checking for. It's making sure that it's being run as root, otherwise it's actually not running any of its functionality. So that looks good. Let me insert a comment here. Check for root. Looks good. And if we have root, then we go ahead and do all of this fun stuff. Okay, B0. Let's see what this is doing. I'm not sure. So let me look it up. Let's do Linux man B0. And let's go to this one. What do we have as arguments? We have, I think, one variable and then one constant value. Not sure. Doesn't look like a char. Decimal 548. Nothing super interesting. What is this variable doing right here? Let's see if it's referenced anywhere else. Nope, doesn't look like it. Okay. So the B0 function erases the data and the n bytes of the memory. Okay, so the second argument here must be the size of the data, I think. Okay, so it's basically just filling this variable with zeros. Nothing too interesting, really. Wonder if that's referenced anywhere. So find references to. Doesn't look like it is. I'll just ignore it for now. And move on to the next line. Looks like we're getting the time. So I'll just name this var time. And we're getting a random number based off of the time. Okay, so this is really common to use the time as the source for the random number generator. And then looks like this is just a temporary variable, so maybe we want to rename this from access return to var temp return. So it looks like this is just the temporary placeholder for all of the different return values that are used in this. Let's hit OK. And then we're copying some data into this particular variable right here, which is going to be passed to this function. So looks good. Give myself a little more space here. It looks like a local variable at a particular index on 10. So I think they're just getting a random index of this variable and copying it into this string. So that's really interesting and kind of weird. Let me see, what is this variable? So I'll highlight it. It looks like we've got 4 different options here. /sbin /udev. Okay. So these are the different options that we have that it looks like it's getting a different index of. And then it's going to be setting that string to one of these. I'm not sure what to name this that's accurate for all of these. Looks like maybe I'll just say folder name or folder command. Let's just say folder command, just to prove that we have taken a look at it. And let's name this one as well. Malware folder destination. Okay, and then we're copying in the string as well to this destination. So what's this string? Looks like it also did not get properly typed right here. So let me see if I can fix this again like we did the other one. I'm going to copy this. We go up to the null character, by the way, because that's going to signify the end of a string. And let me paste that in. So this is a total of 10 characters in our array. So let's right click, retype variable, and then let's turn this into a character array of 10 characters. It looks like it's calling this just try it. Okay, that was hard to read at first. Let me do another comment here. It says, just try it. Surprisingly difficult to read this when it's vertical like this. And similarly, I think I'm just going to go ahead and add the type for this one as well. This looks like another string that wasn't typed. So let me copy this here. Looks like another 10-character string. So I'll right-click on this and do retype variable. Let's make this a 10-character array. Looks good. And this is socket TCP. Well, that's really interesting. I like this one a lot. Socket TCP. So that's our string right there. Let me rename these as well. So let's say, nope, we don't want to retype it. We want to rename it. So we'll just call this var, just try it. Maybe do string so we know that this is a string. And you can name this whatever you want if you're analyzing this. It's just something that you can recognize and come back to know that you actually have figured out what this is. L to rename. So var, stir, and this was just socket, I think. Socket TCP. Looks good. So already our code is getting a lot prettier, so this is getting really exciting. So our stir copy is going to copy our source on the right-hand side into our destination on the left-hand side. Again, you can look up the man page for this as well if you're not sure. So I'm going to call this malware stir, just try it. And do the same thing here. I'm going to hit rename malware stir socket TCP. So it looks like we're going to be setting up some sort of TCP connection, which is kind of interesting. And we have our destination folder here, and we're passing this plus our argument counter plus our argument vector to this function right here. So that's getting very interesting. So I'm going to take a look at this function and see what it does. So I'll just double click to go into it. And maybe we're setting some environment variables. Let's go ahead and label our parameters so we can remember what they are. Make sure I'm full screened here. So we have argc, argv, and then destination folder. So I'm going to name this argc. Name this argv. Remember, these are our command line arguments. And then what did I name? I'll just give it the same name to avoid confusion. Cool. That looks good. Looks like we're doing some stuff with that down here. Let's see where our arguments are used. Let's continue on and let's analyze this function and see what it's doing. Let me see. So it looks like we're getting the environment variable. Let me double check what this contains. So I'm gonna do man Linux, and then let's just do environ. And we can just pick the first page. Yeah, so this is just getting all of the different environment variables. So that's self-explanatory, looks good. Okay, and doing some math. It looks like we're just checking these different environment variables. That's super interesting. You see our argv is stored into here. Let me rename that malware argv. Looks good. So we're setting some memory. Looks like we might be setting a particular environment variable is my guess, since we're doing memset and then string copy. So maybe we're setting an environment variable related to the particular folder that we were looking at. And what I want to know is, what is this prctl before I label this method. This one manipulates various aspects of the behavior of the calling thread or process. That does not really help me. So we have our folder right here, which was one of the different random ones we were taking a look at. And then we have this 0xf in hexadecimal right here. What is this doing? It looks like this is some... So this is the option specified by the integer, but what is the for option for this? Because that's going to tell us what we're actually doing to this and what we're using this folder name for. I think, let me see, maybe it's 1, 2, 3, 4? Not sure. I can look this up, but I think I'll leave this function for right now, and let's just say malware manipulate process. And I'm gonna put a maybe at the end so we know to come back to this and check deeper what it's doing. But I want to continue on. Okay, so daemon change dir, so we're changing to the root directory, and then we're calling this function, which is calling another function, just calling exit. Let's label that malware exit. It's calling signal. What is this signal doing? So this determines how the process behaves when it is delivered a particular signal. So it can listen to a bunch of different signals. So let me name that malware set signal. What is this function right here? So this is changing. This was our path name again. Saying unlink. So this is deleting a file. Oh, okay, so this is getting interesting. So I think this is actually maybe renaming the file that it actually started as and changing it to one of the different names that is specified. So that's very interesting. So I'm gonna call this malware Unlink. That's cool. So it's taking our path name. What was our path name again? Let me see. This is our PID var1, which is the PID. So that's the process ID. And if it equals this, so what is this? Looks like it's undefined. So it looks like this is unlinking our folders. I'm going to say malware check PID and unlink. Looks good. Let me just do references so we can find our way back. We'll do the call right here. Let me make that smaller. So we got lots of calls. Let's just go through and name all these so that we're not reanalyzing them afterwards. Call, check, PID, unlink. We'll find cross references to this one. Interesting. Looks like we've lost our way. Let's go back to our entry point. We can just search by main and come back here. Okay, so we've got our set signal. And then let's see, we're doing another signal command. So it's setting this to wait PID, and we can look that up. So this is waiting for the process to change state. Wait for state changes in a child of the calling process. Okay. I'm going to name this malware call wait PID. Let's go back. And then this is getting our current PID. And then it looks like we're trying to open our path again. And this is going to be the return value of whether the open was successful or not. Then we're going ahead and closing it, and then we're sending another signal. So that was a lot to just change the name of the file and set some waiting for the current process. So let's see what this final function is doing. I'm hoping this actually gives us something interesting. Otherwise, I'll start looking at the strings that we're setting up the socket connection, and maybe we missed something in our analysis and we can go back to it. This is actually looking good. We have a lot going on right here. Okay, so this is also checking our argument vector. So this is probably checking for some different command line arguments as well. So I'm guessing that all of this in our main function back here was just some setup code, and I'm hoping that this function is actually containing some of our actual malicious code. So I think in the next video, we're going to take a look at this function and we're going to see if we can find the actual malicious behavior that might occur after all of this initial setup code. So thanks so much for watching laurieWIRED, everyone. In this video, we started taking a look at the BPFDoor Linux malware. That is a backdoor sample that's targeting Linux machines. We went through and we started to statically analyze all of the different functions, and we labeled them as we went along and found some different setup code, and I think we found the main beginning part of the actual malicious code as well. So in the next video, we'll go ahead and finish our analysis and actually try and take a look at what that potentially malicious function is actually doing. So thanks so much for watching laurieWIRED, and I'll catch you in the next video.